it once again so that the core is very much clear. Okay. So once we are complete with this, we can move on to the next program. Then we'll understand how different programs require different models to be implemented. So first thing that we're going to learn is importing something called as mail data CSV. Okay. So I'll send this particular data set in the chat box. If you don't have this data set, kindly download it. Okay. Mail data.csv. I'll send it right now. Yes, I hope you can see it in the chat box. Correct. Now, same data you are supposed to download, and once you have downloaded it, you are supposed to upload into the collaboratory. So mail data.csv. Once you have uploaded the data set, you should get this. And what you're supposed to do is just double click on it. Okay, just double click on it. Don't worry about all this. I'll explain everything. Just so that is the reason I'm doing it once again so that the core is very much clear. Okay. So once we are complete with this, we can move on to the next program. Then we'll understand how different programs require different models to be implemented. So first thing that we're going to learn is importing something called as mail data CSV. Okay. So I'll send this particular data set in the chat box. If you don't have this data set, kindly download it. Okay. Mail data.csv. I'll send it right now. Yes, I hope you can see it in the chat box. Correct. Now, same data you are supposed to download, and once you have downloaded it, you are supposed to upload into the collaboratory. So mail data.csv. Once you have uploaded the data set, you should get this. And what you're supposed to do is just double click on it. Okay, just double click on it. Don't worry about all this. I'll explain everything. Just double click on it. You can see we have two columns, right? We have two columns. One is called as category, one is called as message. Now, in this first one, category, we have two outputs, or basically two categories. One is called as a spam email. One is called as a ham email. Ham email means it is like a valid email. Okay, for example, hello, how are you? Or meeting is set at 11 o'clock. Such kind of emails are considered to be a ham email or wanted emails. So these are considered as a wanted emails. And what about spam? Spam are considered as unwanted emails. For example, let's say promotions, or let's say ads, or let's say scams. All these are considered as a spam emails. Okay. So what they have done is they have given us 6,567 rows. Okay. Out of which we have spam and ham emails only. We don't have any other mails. We have only two categories, that is spam and ham. So whenever you are having two categories, okay, whenever you are having two categories, or basically whenever you're having what we can say binary outputs, okay, whenever we are facing the binary outputs, then we are using a model called as logistic regression. Okay, I think this is very much clear. Whenever we are having binary outputs, then we are using something called as logistic regression. So how to import it? This is how you import it from sklearn dot linear model, because our logistic regression is a linear model. That's the reason we are importing it from the linear model. From sklearn dot linear model, we are importing the logistic regression. So that's the reason we are importing the logistic regression. Okay. Once the binary, once the model has been imported, next thing that you're going to learn is how to import all the other important libraries. That is the first thing that we are importing is something called as train test split. Now, why this is exactly used? Because you can see 6,567 entries are there, out of which we have to take some part of the data to be a training data. Some part of the data should be taken as a testing data, but always training data should be greater than the testing data. Okay, so that is the reason we are supposed to import this particular train test split function so that it can split the data into training data, split the data into testing data. Okay, so that library is this. Next, once training and testing data has been split up, now we have to put that training data and testing data into our model. Okay, into our model we are supposed to train it. So once we have trained it, we are supposed to check our output, right? So that output, how accurate it is. So the output, how accurate it is, that to check, we are supposed to use a function called as accuracy score. Okay, so basically this will give the score between 0 to 100%. So if it is closer to 100%, then it is a very good accuracy score. That means most of the time it is giving us the correct output. But if it is less than 80%, less than 70%, then we are considering it as a uh, oh, average score. But if it is less than 50, less than 40, then it is a very bad accuracy score. We have to improve it. Okay, next, to convert all the string format into numeric. Now, what do you mean by this? Can you see this? We have the entire text here. Okay, we have the entire text here. So text is not able to understand, right? Accuracy is okay. I'll explain. Don't worry. Can you see this? Once again, yes. Can you see this? If I ask a question with you, with everyone, what type of data can be understood by the computer? What type of data can be understood by the computer? It can understand only two things, right? 0 and 1. So if you provide this data to the computer, can it understand? No, obviously not. Correct. So that is the reason we are supposed to convert this entire string format into a numeric format so that the machine is able to understand it. Okay, so to convert it, basically we are using this. To convert all the string format into numeric format, we are using something called as sklearn.featureextraction.text, because since we are using the text to convert into a feature, we are using feature extraction.text, and the name of the library is tfid f vectorizer. Okay, very complicated name, but still you have to remember, because this is used to convert a string format, string format into a numeric format. After that, basically we are importing the data set, that is a mail data or csv. So let us do it. So click on the first cell, click on runtime, click run cell, and below. No, it is not mandatory to write in chronological order, because all these are basically important, because you can write all this in a one cell also. Okay, you can write in all one cell also, you can write in a different order also, it doesn't matter. Okay, yes. After this, we will do some basic analysis. We have done some basic analysis where we have found out how many ham emails are there and how many spam emails are there by using the value counts function. After that, we have used label encoding. Now, this is a very important part. Please make sure you understand this. We have something called as two categories, I told you, right? One is called as a ham email and one more is called as a spam email. Now, I told you the message, whatever is there, okay, this message. Now, for this message, we had a entire library which could convert a string format into a numeric format, right? That is tfid f vectorizer. But what about this? What about the category? What about ham and spam? Okay, what about ham and spam? So to convert this ham category into, 0, ham category into 1 and spam category into 0, what we have done is we have taken out LOC function, that is a location function. And in the place of row, we have located only the rows which have category is equal to ham, right? And we have in the column, we have taken out only the category column, and we have equated all those items into 1. Okay, so basically we have converted ham emails into 1 and spam emails into 0. Now this is converted into a numeric format, right? And after this, we have moved into something called as separating the mail data into input feature as well as the label. Now, this is a very, very, very important part. Now, without which you cannot understand anything in the machine learning. You have to understand this. I'll explain in a very, very simple manner. Please understand this. Imagine you have built a website. Okay, you have built a website which basically, if any user comes to your website, he or she can enter a email. Okay, he or she can enter an email, and if you click on check whether it is a ham or a spam, I mean, if you have a button called as check whether it is a ham or spam, and if the user presses on it, they should be able to get whether the given mail or the entered mail is basically a ham email or a spam email. Okay, so to do this, can you tell me what input has to be given by the user to your website? What input has to be given to the user? Sorry, input has to be given to your website by the user? Exactly, it is a message, right? So whatever you can see, this X, these are basically the input data that the user has to give to the machine. Okay, X is nothing but the input data that the user has to give to the machine. What about Y is the predicted output that is given by the machine. For example, in this example, if you have given the email to the your website, and the website is able to convert it into a ham or a spam email, basically that whatever output is there given by the machine, that is considered as Y. Okay, that is considered as Y. So in this example, you can see mail data message is considered as the input data. Mail data category is considered as the output, or basically it is considered as a label. Okay, so we have two things, that is input feature as well as label. Obviously, we have two columns, so that is the reason we have one column as X and one column as Y. But while coming to the next program or next project, we might be having more than 5 6 columns. So in that case, we have to extract only one column to be Y, but we have to extract only 5 columns in X. Correct? Next, so we have seen that we have extracted print X and print Y. I mean, input feature as well as a label column. So to check it, we have written print X so that you can see entire input feature, that is a message, and print Y, that you can see zeros and ones now, because we have converted into zeros and one of ham and spam email. Next, now is the time to convert or split the data into training as well as the testing data. So in the beginning, I told you there is a function, oh sorry, there's a library called as train test split function, which converts the data into training data as well as testing data, right? So to convert it, we are using this. Okay, splitting the data into training data and testing data. But while training and testing data has been split up, we have two things now. What are the two things? We have something called as input feature, and we have something called as label. Now the input feature also will have the training data, testing data. Even the label will be having the training data as well as the testing data, right? So we have four variables here. That is X train, X test, Y train, and Y test. Now this is mandatory for all the machine learning models. Okay, this is mandatory for all the machine learning models. Every single machine learning models will have this. Okay, all these four what is the variables. Then we are calling the train test split function, and we are giving the two values, that is X as well as Y. And we are writing something called as test size is equal to 0.2. Now what is the meaning of this? See, test size, that is the testing data, they have mentioned that 0.2 it is. That means 20% of the data will be taken as a testing data. Now, if 20% is taken as a testing data, what about the training data? Obviously, 20 minus 100, that is 80%. Okay. Now, if it is 0.1 here, what might be the training data set? If it is 0.1, exactly, it is 90 percentage. Correct? Very good. Next, once we have split the data into training as well as the testing data, now the time is to convert the text data into numeric machine understanding data. That is, you can see all this text, right? Now this text has to be converted into a machine understandable language. So to convert it, we are using the TF-ID F vectorizer, and we are mentioning these words. Now these words and these parameters are very much important, because we have some letters as capital, some letters as small case. So that is the reason, first of all, we are converting everything into a smaller case. Then we are mentioning all the words that we have in our data set is a English language. So you can see most of the words are in English. Then here we are mentioning minimum df is equal to 1. That means minimum there should be one data frame in your data set. Otherwise, it will not run. So that is the meaning of minimum df is equal to 1. So these three parameters, once you run, you can see now the text has been converted. No, that it is not directly converted into what is that? Yes, this is not directly converted into a numeric format. What you have to do is, first of all, you have to call x train, you have to call x test, and you're basically converting into a numeric here. Can you see x train numeric, x test numeric? Because in the x, that is the input data, we have this message, right? So training data also have this message. Testing data also have this message. So we are converting that into a numeric. First of all, what you're doing is you're calling the feature extraction. Then for the training data, you are fitting and transforming the data. But for the testing data, you are just transforming. Now, this is the key difference between the training as well as testing. You have to make sure you have to understand this. For training data, you're fitting as well as transforming. For testing data, you're only transforming. Okay. Now, once it is being converted into a numeric format, next thing is to convert the y train as well as the y test into integers. Why exactly we are supposed to convert it? Because even though we have converted into zeros and ones, okay, even though we are converted into zeros and ones, there is a high chance that the data type is object. Can you see? D type is equal to object. Now, object means all these values are basically enclosed inside a quotes. Okay, inside a quotes, it is been what is that? Saved. So to remove this quotes, if it is obviously it is quotes, it is again considered as a string data type. So we cannot use that, right? So we are manually changing that to a integer data type so that the quotes has been removed, and we are focusing just on the numbers. After that, now we are basically training the model. Now, whatever we have done till now, this is actually the first step. Can you see this? Setting up the data. This is actually the first step. Now, setting up the data, whatever we have done till now, is just one step. That is setting up the, first step. Now, creating the model, training the model, testing the model, and prediction. Now, this is actually very easy. Okay. Only thing that is difficult is to understand the setting up the data. Creating model, training model, testing model, as well as the prediction is actually very easy. So to understand this, you can see the till now we have done only the setting of the data, but training, testing, and prediction only is is only so much. Can you see? Is only so much, and most of the things is actually repeating. I'll tell you how it is repeating. First thing that you're going to do is you're calling the model. Very simple. You're calling the model called as logistic regression, and you're saving it in some variable called as model. After that, you're training the logistic model with the training data. Very simple. Okay, you're training the model. Okay, training the logistic regression model with the training data. How to train the model? You're calling the model. You're using a function called as fit, and you're giving both the x train num as well as y train. Okay, training data you're giving. And once it is been trained, now we are supposed to check the accuracy score. In the sense, how accurate it is to give me the output. Okay, so you can see I have mentioned model.predict. Okay, we are predicting the x train num, and we are finding the accuracy score of the training data. To find the accuracy score, we have found out, we got the accuracy score function, and we have given the training data, and we have found out the training data accuracy. You can see 0.97. That means 97% is my accuracy score. Okay, I told you anything that is greater than 90% is considered as a good accuracy score. So most of the time I might be getting the correct answer. Now, what about the testing data? Now, here, what we have done is, again, we have done the same thing where we are evaluating the testing data instead of what is that? Training data. So we are just copying this. Okay, we are just copying this and we are pasting it here. And wherever you can see training, you have to convert into test. That's it. Okay, wherever you can see train, just change that to text. You can see test here, you can see test here, testing, and you can see 0.96 is our test accuracy score. So I can say 96 percentage of the time I'm getting the correct answer. Okay, only there is a chance of getting 4 times out of 100 that is wrong answers. Next, once everything has been completed, now we are building a predictive system. That means you're giving the input data. Now this input data actually should be given by the user. Okay, this input data has actually should be given by the user. So we have mentioned one particular email, one random email, and we have obviously if you give this to the machine, it will never understand. So what you're supposed to do, you have to convert that into a numeric format, just like we have done for the message. So same exact thing we are doing here, that is feature extraction dot transform, and we are giving that input data here. What happens now? Now this whatever data has been there or whatever message has been given, that is been converted into a numeric format. Now this numeric format we have to predict according to the model. Okay, we are calling the model, we are predicting it according to the input data numeric. And if the prediction is saying 1, okay, if the prediction is saying 1, that means it is a ham email. If it is not, then it is considered as a spam email. Now if you just see this particular message, lottery, you have won a car, please click on this link to avail this offer. Obviously if you see this data set or if you see the message, you'll obviously know that this is a spam email. So if you run it, you are getting something called as a spam email. Now what I'll do is I'll just change this message. Okay, I'll just change this message and I'll give some other message, let's say free, 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 uh, val. Yes. If you just see if you see the input data, can you tell me what type of input data this is, or what type of email this is? Whether it's a spam email or a ham email. I want everyone to answer whether it is considered as a ham email or a spam email. Obviously, it is a spam email, right? So let's run it. Let's run it. Can you see we are getting the correct answer? That is the spam email. Now what we'll do is we'll change that. We'll change that into very simple email. Let's say hello, how are you? Now, obviously, this should be converted into a ham email, right? So let's see. Can you see? It has been converted into a ham email. So basically, we have built a system where it can predict whether the given mail is a ham email or a spam email. Now, whatever we have done is a very basic one, but actually there are some different parameters that we have to go through, because every time if you see this, it is not, first of all, it is not just English that we are talking about. There are different languages that you have to train, right? If you're building a very big model, we have to train it according to the different, what is that, languages. So to do that, we require a lot of data, we require a lot of computing power, we require a lot of training as well as testing. And most of the time, we won't be getting this. Okay, most of the time, if you're a machine learning engineer, there is a high chances that you'll never get this 97 percentage directly. There are some methods, there are some statistics that you have to do so that you can improve this accuracy score. But as of now, as you're learning the basics, I don't think so all these are very much important. But if you want to become a machine learning engineer, if you want to become a machine learning expert, then most of the things that we have done in the first step will take you at least a month. Okay, I told you, whatever you have done in the first step, it will take you months to complete. Then second, third, fourth, and fifth is basically very, very easy. Okay, you can finish off in 10 minutes. But first step is very difficult to understand and very difficult to perform also. Because whatever you can see, this 0.97, you'll never get it directly. Okay, since it is a very simple what is the data set, we're getting it very directly, but most of the time we'll never get it. Okay, next. So I hope now everybody is able to understand what we have done in the first training, was machine learning model. Any doubts as of now? So what we'll do is we'll take the same set of data set, okay, same exact same of set of data set, and we'll create one more machine learning model so that you can understand it better. Can we do it? I want A's in the chat box so that we can start. Okay, very good. Everybody, I want you to create one more text and here write something called as uh, yes, I want everyone to write this machine learning project 2. Once you complete this, kindly write, kindly give a thumbs up in the chat box so that we can start machine learning project 2. Okay, let's write this as machine learning project 1. Okay, completed. So let's minimize this. Okay, completed everyone. Okay, now I told you we are completely focusing on the previous project, right? So first of all, just copy the workflow of the scikit-learn because exactly same workflow we are going through. Okay, so let us quickly paste it here. Yes. Okay. So this is the workflow of the scikit-learn. Again, let us understand. First of all, it is the setting up the data. I told you 80 or 90% of the work is only creating, setting up the data. Rest, creating model, training, testing, and prediction is actually very, very simple. Okay, as of now I'm telling it is very much simple. It is not actually very simple. If you're creating very big models, it is not that simple to creating testing all those models. But as of now we are understanding that setting up the data takes off a lot of time or lots of effort, but all this will take a very less amount of time. So let's run this. Okay, let's move on to the next one. What we have done in the next, we have seen that we have imported the important libraries, right? So we'll do the same thing here. First of all, we want NumPy as well as the pandas. We want the model here. We want the train test split function. We want the accuracy score. Uh, we don't require this. I'll tell you why. Okay. And we are importing the data set. Okay. We'll quickly do it. I don't want everyone to copy this. Please kindly make sure you are writing it so that you are, getting a practice. Importing important libraries. Okay. So first thing that I'm going to do is importing the NumPy. Import NumPy as NP. After that, import pandas as PD. Okay. Let's run this. After converting, after running this, we'll move on to the next one where we are importing the model. Okay. I'll tell you what type of model we are using, but before that, let us import other other libraries. That is importing the accuracy score. So importing accuracy score function. So let us import from sklearn dot metrics. Correct. Import the accuracy score. Kindly make sure you complete this everything. After this, we have the, what else is pending? Okay, one is this train test split function. Correct. So we'll see what we have written. If you have any doubts, you can just go back and see whatever we have done it here. Okay, you can see importing the train test split function. Just copy it if you want it. Okay, I think after this we have basically imported the data set. So we'll let us write here importing the data set. So the data set we are gonna use here is called as breast cancer data set. Okay, so I'll be setting that data set in the chat box. I want everyone to kindly download it. Okay, please download it. I've sent you just now, and upload this data set into your collaboratory. So breast cancer data.csv file. Now again, this is a CSV file. Okay, once you have completed with it, I want again you to give a thumbs up in the chat box. Okay, so let us convert again this into a data frame. df is equal to pd dot read underscore csv and mention the name of the file, that is breast underscore cancer underscore data. Let me check once again. Yes, breast underscore cancer underscore data dot csv. Let's run it. Let's run the df now. Okay, let's run the df and check what is our output. Okay, so this is our output. Now kindly make sure you understand this. I'll quick close this. Okay, yes, I request everyone to see this properly. Okay, I request everyone to see this properly. uh Everyone, First of all, give me a thumbs up once you have uploaded the data set and you're getting the data frame, because I want everyone's attention here. Give me a thumbs up once you have uploaded the data set and you're getting the data frame. Or kindly write yes in the chat box. Be quick. Okay. Now listen here properly. Okay. We have something called as ID. Okay. First of all, see how many rows we have. We have 569 rows and we have 33 columns. It is not one, it is not two, it is 33 columns. Okay. And in these columns, there is one particular column that is basically a diagnosis. Can you see? There is something called as diagnosis. Obviously, we don't require this ID. So in the later part of the session, what you're supposed to do is we are supposed to remove this particular column. I already told you how to remove the particular, any particular column. So I want everyone to be ready to tell me how do we remove a one particular column. Now, I told you we have something called as diagnosis. And here you can see something called as M. We can see something called as B. What is the meaning of this? See, in breast cancer, there are two types of tumors. Okay, I'll write that here. Two types of tumors in breast cancer. Now, these two types of cancers, or basically two types of tumors, are very good. Yes, it is. One is called as malignant. Okay, one is called as malignant, and one more is called as benign. BENIGN. Okay. Now, I told you one is called as malignant and one is called as benign. Is it? I don't know the spelling. Let me check. BINI. No, GN it is. Yes, it is BENIGN, not NINGN. Okay. Malignant and benign. So two types of tumors are there. One is called as malignant and one is called as benign. Now, usually doctors say that benign is a treatable tumor. Okay, it is a treatable tumor. But what about malignant? It is not treatable. Okay, it is actually very severe. Okay, it is, I mean, this malignant is actually very severe. That is non-treatable tumor. And benign is considered as a very treatable tumor. In the sense, it is the first stage of cancer. So we have something called as M and B. So can you tell me, out of this diagnosis, how many categories we have? I want everyone to reply. How many categories we have in this diagnosis column? Obviously, it is two, correct? One is called as malignant and one is called as benign. So whenever we are having two outputs or whenever we are having two categories, what type of model are we supposed to import? It is not just a regression. It is not just a regression. There are different regression models. What exactly are we supposed to use? I told you we are supposed to make sure we are using a logistic regression. Can you see this? It is logistic regression. Now, why exactly we are using logistic regression? Because logistic regression works perfectly with whenever we are having binary output. Okay, so we'll copy this, we'll paste it here, and let's run it. Okay, now we have imported the model, we have imported the accuracy score, we have imported train test split function, and also we have imported the breast cancer data. Now we'll do some basic analysis. Now let's say I want to check number of benign and malignant tumor. Okay, how to do this? I want everyone to tell me how we can check exactly. It is value count. So first of all, access that particular column that is called as diagnosis column, right? So we'll copy the name of the column, diagnosis, and make use of the value counts function to check how many values are there. Let's see, value underscore counts, open and close bracket. Obviously, we are supposed to make use of the reset index also because it is not giving me in the single row. Okay, you can see B as 357. So M is 220. So most of the cases are treatable, that is benign, and some cases are basically malignant. Okay, so we have this analysis now. Now, the next step that you're going to do is we are supposed to remove this particular column. Okay, I want everyone to tell me how we can remove this particular column, that is ID, because ID doesn't make any sense here, right? Radius mean, texture mean, perimeter mean, basically all these are important data. But this ID, this is just the reference, so we do not require this. So what we are supposed to do? Exactly, we are supposed to drop, correct? So removing ID from the data set. Okay. So what are you going to do? df dot drop function. And inside that, you have to give the name of the column, correct? So what is the name of the column? Name of the column is ID. But how we can give the name of the column? We have to mention columns is equal to ID. Okay. Now it has been removed now, right? But if I go to the new cell and if I run the df, you can see that ID is still there. So what is the solution? We have to permanently delete it. That is in place. Very good. So in place is equal to true. We have to write so that we can remove it permanently. So we have removed it permanently. Let's run the df once again. Okay, now the ID column has been removed. So now how many columns do we have? We have 32 columns. Okay, very good, guys. Perfect. Now we'll move on to the next, where we'll understand some more things. Where first thing you're going to understand is uh, okay, first thing that we're understanding, what is the data type of all these columns? Okay, how many columns we have? That is 32 columns. I want to check what are the data types of these columns. So to check the data types of the columns, what function do you think I might be using? Or what function do you think is the best so that we can find the data type? Okay, one is d type, but I want to check for each and every column. So can I write no? Checking the data type. Okay, so this function, I'll give you a hint. This function will tell you exactly, Sanjay. Very good. Sanjay, it is the info function, right? df dot info function. Now, what this exactly does, it will check and tell you whether we have any null counts or not. Otherwise, it is giving me the entire data type. Can you see object, float 64, and everything we are able to get. So basically, everything except the diagnosis is the integer data type. So are we supposed to convert anything? No, right? We are not supposed to convert anything because everything is in the integer data type or basically numbers. So numbers are, I mean, if it is in the numbers, machine is able to understand? Yes. So we don't have to convert anything. We directly have everything in our hand. The only thing that we have to convert is this. That is a diagnosis. So diagnosis, we have two, that is B and M. So can you tell me what are we supposed to do? What are we supposed to do here for the diagnosis? We are supposed to convert this B and M just like the spam as well as ham into 0 and 1. Okay, very simple. So if you see this data type, I mean, if you see the info function, there is one column that is unnamed 32. Can you see this? Unnamed 32, and you can see 0 and 0 non-null. In the sense, there is no data at all. So is there any sense to keep this particular column? No. So let us remove it. I'll just copy the name of the file, I mean, name of the column. And we'll write it separately. Now let's run the df.info. Yes. So the last column has been removed now, correct? Yes. Now the primary thing that you are supposed to do is convert this diagnosis into zeros and ones so that the machine is able to understand it. But before that, let's check whether we are having any null values or not. Checking null values. Okay, what am I supposed to do? Which function I'm supposed to use? It is df dot is null function, right? So let us use the is null function. And let's sum it up to check whether we are having any null values. Okay, from the beginning we can see 0 0 0 and there is no null values. So most of the time this might not be the case. Okay, this might not be the case because sometimes we deal with null values And to deal with null values, whenever we are having the null values, there are some different methods that you are supposed to follow. As of now, they are not using it because it is very, very advanced, because you have to understand statics first. I mean, if you, okay, how many of you know statistics? Not the basic statistics I'm talking about. If you're taken PCMS in your PU, anybody? No one, right? So statistics plays a very important role in the machine learning, where I mean, where you're supposed to use different formulas and different uh, understanding of statistics, so that you can treat with those null values without changing the measures very drastically. Okay, we are supposed to take the average of something, and we have to, okay, this is basically too much, so I'll not go there. So checking the null values has been done, completed. Now we'll move on to the next one, where we'll check okay, now what we'll do is we'll go to the input feature as well as the label. Okay, so let me write here, input feature is X, label, and this label is actually called as a target column. Okay, target column is nothing but the column where it is based, I mean, where the machine is able to predict. Okay, so input feature is considered as X, label is considered as Y. Okay, now after this, basically we are supposed to convert the everything into the X and the Y. But before that, I want everyone to tell me, we are supposed to, let's come to the next cell and run the DF. Okay, if you see this, you can see we have something called as M and B. So the primary thing that we are supposed to do is convert this into zeros and ones. So what column we are supposed to give it as 0, and what column we are supposed to give it as 1. So I'll write that here. We are convert Benin, that is B, okay, B to 1, and M to 0 in the diagnosis column. So to do this, first thing you're going to do is you're writing a LOC function, that is a location function. And inside that, you're providing, and you're writing a condition where df of diagnosis column should be equal to B, right? It should be equal to B, and we are supposed to extract only the diagnosis column from the column parameter, and we are equating that to 1. Okay, so we are doing the same thing. Okay, something is wrong. uh 1 second. Okay, we are getting it. So why it is wrong? Okay, so if you are having any doubts, go back to the previous model. Square bracket, where exactly? Oh, I'm sorry, we have forgot the square bracket here. Exactly, I'm sorry. Now is it right? No, let's check. Okay, let me check for the previous one. Okay, so basically it should be in, okay, I'm sorry, it should be inside a square bracket itself. Now is it? Yes, now it is perfect. I think this is not required. Middle category, yes, this is not required. Okay, perfect. Now we'll copy the same thing. We'll paste it here, and let us write M and this should be converted into 0. Let's run. Okay, perfectly running. Now let's check for the data frame. It should be converted into zeros and ones now. Yes, perfect. So diagnose, you can see every single thing which is basically M, that is converted into 0, and B is converted into 1. Okay. So basically, we have converted every single value into a numeric data type now, right? Once you are converted into a numeric data type, now we can move on to the next step where we can understand that how to convert into an input feature and what to convert into an input feature and what to convert into a label column. Okay. So if I run the data frame, just look at it and tell me what column has to be taken as the input feature and what column has to be taken as the target column. I'll explain it what is input feature and label once again. Now, based on that, you are supposed to give me the answer. Now, imagine you are again creating a website. Okay, you are creating a website and whatever input that is given by the user, okay, whatever input has been given by the user has to be converted as, has to be considered as an input feature, and whatever is being predicted by the machine, okay, whatever is being predicted by the machine is considered as a label column. So can you tell me out of this entire column, what is the column name? Okay, what particular column name is considered as the output here, or what is the column name that the machine is supposed to predict? Anybody? I'll repeat my question once again. What is the column in this particular data set? What is a column that the machine has to predict? Once we give some value, it has to predict something, right? So what is that column? Exactly. Very good. It is diagnosis column, right? So diagnosis column is a column where the machine is supposed to predict. Now, if the if I consider the diagnosis column as the target column or the column which is basically predicted by the machine, what is the column or what are the columns that should be considered as the input feature? Rest all of the columns. In this case, rest all of the columns. Can you see this? Rest all of the columns should be considered as the input feature. Okay, based on this, it is supposed to predict whether it is a malignant or a benign, right? Based on that, it is giving me the output as Y. Otherwise, it is giving me, otherwise the user has to give all these values so that he or she is able to give he or she is able to get the output as 0 and 1, that is malignant or benign. So to do that, first thing you're going to do is writing the X, that is the input feature, right, is equal to what you are doing out of this, because we want every single column, but we do not require just one column. I'll repeat once again. We want every single column, but we do not require the diagnosis column, because diagnosis column is the column that is being predicted by the machine. So what we are doing is we cannot directly write all the columns here, but what you can do is we can make use of the drop function. So what you're doing is we are dropping one particular column. Which is that column? The column is the label column. The diagnosis column. Diagnosis column. And we are mentioning the axis. That is axis is equal to 1. So if I run this, and if I run the, if I want to check the X, you can see the output where the diagnosis column is not there now, but rest all of the columns are there. Can you see? Rest all of the columns, that is 30 columns are still there. So X has been completed. What about Y? Y is diagnosis column itself, correct? So Y, let's consider it as df of diagnosis. Can you see? Now let's check for print X and, let's write print X and print Y to check the outputs. Print X. You can see we have the 30 columns, and let's move to the new cell, and here let me print the value of Y. And if I do this, you can see the values, that is zeros and ones, correct? Now this is the column that the machine is supposed to be, predicting. So that is the reason we have this as a separate value. Okay. So I hope exactly whatever we have done in the previous model, exactly same thing has been repeated here also. Now after this, what we have done in the previous model, what have we done in the previous model? Anybody? We have split the data into training as well as the testing data. Exactly. Very good. So we have to convert this values into training as well as a testing model. Now, this is actually very, very simple. What you have to do is just go back. Okay, just go back to whatever we have written in the previous model and keep on copying and pasting. Okay, because everything is exactly same. So let's go back. Okay, we were here, right? So exactly same as this. Copy and come down and paste it here. Okay, let's run it. So you can see total number of values were 569. Okay, we had 30 columns. Then 80% of the data, that is the training data, has been taken as 455, and 114, that is 20% of the data, has been taken as the testing data. After this, what we have done? After this, basically we have written, let's go back, let's check. Okay, after that, what we have done, we have converted the text data into numeric machine understanding data. Now, is this required in our second data set? Is this required in our second data set, transforming the text data into numeric machine understanding data? No. Why doesn't require? Because we don't have any what is that, string data type, right? We don't have any string values. Here we had string values, so we are supposed to convert it. But there we don't have any string values. We have everything in the form of numbers, so we don't have to convert it. But what about, okay, so I think this is done. So here also, this also is not required. Even this is not required because everything is still in numeric data type. So the thing is coming to the training the model, correct? So the last step is to basically train the model. So we'll call it model is equal to, from here, well, will not copy, will write it because it's very important from here. I suggest you also kindly don't copy it, write it. Okay. So we'll call the model, that is logistic regression model. And from here onwards, we'll train the model. Okay. Model training. So to train the model, first thing you're going to do is you're training with the uh, training data. Okay. You're fitting the value with the, fitting the model with the training data. So we are calling the model and you're using a function called as fit, and you're giving the training data, that is X train as well as the Y train. Now once, I'm sorry, unknown label type unknown. Okay, this is strange. We are supposed to get it. Maybe you're trying to fit a classify which expects a discrete class of regression target to continuous values. Okay, this is strange. We were supposed to get it. Logistic regression. No, value error. Model training. Okay. Extreme Y train is there. I think we have missed something. No, it is not extreme Y test. I mean X test. It is exactly the same thing. Let's go back. Let's check. Okay. Here we have basically written extreme num because we are converted into a numeric format. But here we don't have to do it because already it is in a numeric format. What else is wrong? Something is wrong. Uh, Maybe any single column has any other data type. Let's check in info function. Okay, everything is float 64 only. Let's run it once again. Okay. Every single thing is float 64, so I don't think so anything is. No, removing the diagnosis column is required because we have splitted the data into the target as well as the input feature, because here we have to remove it. If you think that diagnosis column is not there, it is there. It is simply that it is present. I mean, in the X, it is not present. That's it. That's the only difference. Okay. But I don't think so. Why we are not getting it? Print Y. Okay. X test. String X test. Y trim Y test. X Y. X table. Okay. Logistic regression model dot fit. We are supposed to get. I don't know why we are not getting it. Unknown label type. Just give me a minute. Okay. It's running perfectly. Uh, mhm. Maybe I don't know because 1 second, just a minute. What I'll do is I'll not remove this. Okay. I don't know. Maybe this is a problem because this give me the wrong output. No, still the same error. Input X contains, yes, NaN. So NaN means I mean null values. It has to be removed. So we'll get back and let's remove it. Okay, now it is removed. Okay, so what we'll do is, see, we have this data set, okay, but this data set is actually inbuilt in, library, okay. I mean, this is actually the first data set that is been that you are supposed to learn under the machine learning, okay. So what we'll do is, instead of manually writing this df, we can get that from the data. I mean, we can get that from the data frame itself. So to do that, what you're supposed to do is, we are supposed to, you don't do it, okay. As of now, you don't do it. I'll tell you what you're supposed to do later on. First thing that you're going to do is importing the data set, not like this. I'll import the data separately. uh, Import sklearn dot datasets. Okay. So this is actually the data set. Now from this data set, we have to extract, the columns as well as the feature names. So to do that, we are writing pd dot. Don't do it again. Again, I'm telling you, don't do it. First of all, let me finish it. Then I'll let you know what you're supposed to do. Okay. Now here, okay, now it is running. Maybe the data set is wrong. Don't worry. As of now, I'll let you know what you're supposed to do. Okay, it is actually it is a very much very much similar data set, but the only thing is some values are being changed here. Okay, some columns are being kept in different places, so maybe that is the problem because everything that we have written is exactly the same thing. Okay, so logistic regression is a more suitable minor operations. You can see model we have called it, and the logistic regression we have called it, and we have fitted the train data, that is X train as well as the Y train. Now, according to this, now what you're gonna do is we are gonna do the prediction. Okay, that is the train data prediction. So you can go to the previous model also. You can check how we have done the accuracy score. So to check accuracy score, now you're supposed to not. I mean, you're not supposed to do it because I'll tell you what is the solution for the previous data set itself. Okay, while coming to the next class, I'll tell you. Otherwise, now only I'll tell you. Okay, checking the accuracy score. To check the accuracy score, first thing that I'm going to do is we'll write something called as X train prediction, because first thing that you're going to do is you are supposed to predict, and based on the prediction you are supposed to find the accuracy score. So first thing I told you, we are supposed to predict based on the model, sorry, based on the training data. So X train, let's run it. So it is predicted now. Once it is predicting, now we are finding the training data accuracy. Accuracy is equal to, we are calling the accuracy score, and we are writing the Y train along with the X train prediction. X train prediction, right? And after this, we are printing the accuracy score of training data. So training data accuracy. Let's copy, let's paste it here. Let's run it. Okay, so we're getting 0.94. Now is 94% I am getting as accuracy score, which is again considered as a very good accuracy score. Okay, so we'll do the same thing for the testing data as well. So we'll copy the same thing. We'll go back to a new cell. And here, wherever you can see train, just change that to test, X test prediction. Here also, let's change that to test, testing data accuracy, Y test, X test prediction, accuracy score of testing data accuracy. Let's check. Okay, here you are getting 0.92. That means 92% is your accuracy score. So you can see 94 and 92, which is considered as a good accuracy score. So when you're having such kind of accuracy score, obviously you can move on to the building a predictive system or basically predicting. So here, well, building a predictive system, and to build it, first thing that you're going to need is input data, right? So input data. And first for timing, let me keep it blank. I'll tell you why. And whatever this data is there, okay, whatever this data is there, you can see it is not in the list. I'm sorry, it is in the tuple. Okay. Whatever data you're supposed to give, that has to be given inside this common brackets. And whatever this data is there, this has to be given to the machine in one go in the sense, how many data we have in, I think we have 29 columns, right? So 29 columns has to be given as one data. So to that one data, whatever is there, so the machine is able to understand. We call it as something called as data point, one data point. Okay. So to do that, first thing that you're going to do is we are supposed to convert this input data into NumPy array. Okay. So input data, we have to convert into NumPy array. So to convert it, first of all, you're calling the NP, that is NumPy. Then you're using as array and you're mentioning input data, right? After that, you are supposed to reshape this input array, sorry, this NumPy array as one data point. Okay, we have to convert this into one data point. Why? Because I told you this 29 columns that we are gonna give inside this input data has to be given as one data point to the machine so that it is able to understand it. So to convert it, we are writing this. So we are writing input data reshape so that we can reshape it. Reshape is equal to, we are calling input data as NumPy array, and we are using a reshape function, and we are supposed to write something called as 1 comma minus 1. Now this is the meaning of converting into a one data point. Okay, let's run it. Quickly running, and after this we can build, prediction for the one data point. We can do it. So let me write here prediction for one data point. So the prediction, first of all, you are supposed to predict according to the input data. So prediction model dot predict. It is exactly like the previous one. You can just check for the previous one. It is exactly the same thing. Input data reshape. And we are writing if the prediction is equal to 0, then we are supposed to print breast cancer is malignant, right? Now else we are supposed to print breast cancer as benign. BENIGN. Okay, so since we have not given any data set now or any data as of now, so we don't have anything. Okay, what we are supposed to do is kindly you are supposed to go to your data set that you have downloaded. That is the breast cancer data set. You are supposed to go to that. Go to that particular data set. That is breast cancer data. And you're supposed to open it with the help of Notepad. Okay, I want everyone to open the breast cancer data set with the help of Notepad. So this is output you're able to get, right? You can see this is output. And here you can see ID as the first column, diagnosis is the second column, that all this you can see. I told you ID we don't require here. We don't require the diagnosis also. Why? Because diagnosis is the term that the machine is supposed to predict, correct? So we are ignoring the first two columns and we are supposed to copy everything except the first two columns. We are supposed to extract everything. So from the 17.99, we have to extract till the last column, that is 0.1189. Now, in this case, you can see the prediction is actually M, that is malignant, correct? So that same data has to be given inside this input data. Okay, and run it. I'm sorry, we have given the codes. Codes is not allowed. Yeah, let's give the values. Yes. Now let's run it. Okay, can you see? The breast cancer is considered as a malignant. So basically, our system is working. But I don't know why we were getting the output as wrong output. Don't worry, I'll fix it and I'll let you know soon after this. And we'll try for Benin. You can see any Benin's values here. Okay, M. I want B, any B. Okay, here you can see one B, right? So we'll copy the same values once again of we have copied it. Minimize. We'll change the values and let us paste the new values now. Let's run it and let's run it here. Can you see the breast cancer is considered as a Benin output now? Now, obviously, you can give your own data set here. Okay, you can give your own data sets, but you have to be very much careful. Why? Because all these are being tested and given to the machine. Okay, it is not randomly we can give it. Obviously, it has to be tested and it has to be given to the machine. So that is the reason I've just copied from our existing data set and I'm giving the output. I mean, giving the prediction. But if you're getting your own data set, it is well and fine, but it has to be given perfectly. What you can do is you can go to ChatGPT. Okay, you can upload this particular data set, that is breast cancer data set, and you can ask one particular data that I'm supposed to give as the input data. Okay, and we ask whether the given data is malignant data set or a benign data set. So what it will do is it will tell you whether it's malignant or a benign, and based on that you give this output. Okay, I mean this input, and run it and check whether it is giving you the correct output, that is benign or malignant. Okay, I hope whatever we have done till now is very much clear. Any doubts as of now? Any doubts? So I told you this is one problem that we have faced in today's class. I'll fix it. Don't worry. While coming to the next class, I'll fix it. uh I was supposed to do one more model of the machine learning. Can we do it? Or well, end of the class? I want everyone to reply in the chat box. We will continue with one more model or we'll wind up. Okay, end class. Okay, fine. No problem because we have half an hour still. We have half an hour. So while coming to the next class, I want everyone to understand these two models. Okay, based on these two models, we have one more